The transform operator allows you to take a relation of a specific order and type and transform it to a new order and type. For example, if we had a relation that paired each SMD pad object with each component that the SMD pad is not a child of, a relation of order 2 and type SMD pad component, we could use the transform operator to transform the input relation to a relation of order 3 and type SMD pad component number, so that each tuple will now include the distance between the SMD pad and the component. We'll break down a simple example of a transform to operation using a small design as 3 SMD pad objects and 2 component objects. SMD pad object SMD1 is a child of the component C1, and SMD pad object SMD2 is a child of the component C2. The SMD pad object SMD3 is a standalone pad and is not a child of any component. The syntax for the transform operator is the transform keyword and then the 3 required arguments. The 3 required arguments are a list of local variables, an input relation, and a transformation function. For each tuple in the input relation, each constituent of the tuple will be bound to the variable names in the variable list. The transformation function will then be applied, producing a new tuple with a different order and type for the output relation. For our example, we start with the transform keyword followed by a list of 2 local variables enclosed in parentheses, SMD and comp. The second argument to the transform operator is the input relation, which in our example is the output of the select operation. This select operation is broken down in detail in a previous video, which can also be found at support.cadence.com by searching for the video by its name, a RAVEL select operation. We soon define this relation for our example design, but we know that the input relation must have an order of 2 because there are 2 variables in our variable list. Finally, the third argument is the transformation function that will be applied to the input, which we will be discussing in more detail. We start our example with the input relation to our transform operation, which will be the output of the select operation. This select operation will first combine every SMD pad with every component in the design, and then select just the SMD pad component pairs where the SMD pad is not a child of the component. The relation will be of order 2 and type SMD pad component. And based on our example design in the upper right corner, the size of the relation will be 4, giving us the tuples SMD1C2, SMD2C1, SMD3C1, and SMD3C2. This select operation is broken down in detail in another video found at the link shown. This entire select operation and the relation that it outputs is the second argument to our transform operation, the input relation. Notice that the relation is tuples of order 2, which matches the number of variables in our variable list for our transform operation. The transform operator will iterate over each tuple in the input relation, so in our example there will be 4 iterations. For each iteration, each constituent of the input tuple will be assigned to the local variables, and the transformation function will then be applied. Our example transformation function will return a tuple of order 3. The first constituent will be the object stored in the variable comp, and the second constituent will be the object stored in the variable SMD. The third constituent will be a number returned by the distance measurement. The distance measurement takes 2 objects and returns a number, the distance between those 2 objects. Our transformation function will take the input relation of order 2 and return a relation of order 3. For the first iteration, the SMD1 object will be assigned to the SMD variable, and the C2 object will be assigned to the comp variable. The tuple for the first iteration will be the object stored in the variable comp, the object C2. The object stored in the variable SMD, the object SMD1, then the number returned by the distance measurement. the distance from the object stored in SMD, the object SMD1, to the object stored in the variable comp, the object C2. For the second iteration, the SMD2 object will be assigned to the SMD variable, and the C1 object will be assigned to the comp variable. The tuple for the second iteration will be the objects stored in the variable comp, the object C1, the object stored in the variable SMD, the object SMD2, then the number returned by the distance measurement, the distance from the object stored in SMD, SMD2, to the object stored in the variable comp, C1. As we iterate over the rest of the tuples in the input relation, each input tuple will be transformed from order 2 and type SMDPad component to tuples of order 3 with type component SMDPad number, where the number is the distance between the first two constituents of the tuple. This type of relation will be useful for checking SMDPad to component spacings in a design. Our transformation example took a relation that had pairs of SMD pads and components for every SMD pad and component in the design where the SMD pad was not a child of the component, and transformed it into a relation of order 3 that had every SMD and component in the design along with the distance between those two objects.